It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always with me, Andy Grabner. Andy, are you there?
I am there,
hey.
And I know we are both excited about this episode.
Yeah, and you know, I have to say it's funny because as the theme music was playing, I realized, you know, there's one instrument that's not present in that theme music, and it's very relevant to our guest today. Can you guess what
would that be? Come on. Throw it out there.
There's no six-string guitar.
Yeah.
I say that because there is a bass in there, but that's so it's, I guess there's some relevancy because there's a bass guitar in there, so that's extremely relevant. But before we go on, Andy, how have you been? It's been a long time since I talked to you. What, two days, 3 days?
Yeah, about that. Yeah, actually, a lot happened in last weekend. I actually saw Dan Auerbach playing at the House of Blues, which brings me again back to the theme that we have today, or the guest of honor. Very interesting concert. I've never seen him before. I was very, very happy to be brought into that concert. Yeah,
that's cool. I didn't know you played.
Yeah, in Boston, House of Blues.
Yeah,
very cool.
Nice. So, why don't you introduce our guest today?
Just as we talked about performances, where obviously we talk about performance today, we talk about serverless performance, and the guest we bring in is Michael Garski. Hopefully I say this correctly, Director of Platform Engineering at Fender Musical Instruments. Michael, are you there with us?
Yes, I am, and you got that pronunciation proper.
Awesome.
Perfect. Where's the last name come from, if I may ask? Garski?
It's Polish.
Polish? Cool. We have a large engineering team out of Gdansk in Poland. Do you happen to know where your ancestors come from? Or you, maybe? Were you born over there?
I do not know. I grew up in Wisconsin area, so there was lots of ski names everywhere.
All right. Cool. Hey, Michael, thank you so much for the show, for coming on to the show, and for obviously also doing a good show with us today. And
thank you. It was a good show. We'll wrap it up now, and we'll talk to you all.
Exactly. It was the shortest podcast we ever did. No, but seriously, so you actually presented at the AWS Loft recently, and you also told me that you also presented at the AWS reInvent last year. And I think the title of your presentation was Innovating Through React Native Mobile Apps. And one of our colleagues, Bill Sajak, he saw it and he said, hey, guys, you need to interview Michael because it's very interesting to learn more about the architecture of what Fender actually built their applications on and learning more about serverless performance. So, Michael, I want to just throw it over to you. Maybe start out with, for people that don't know Fender, who is Fender? And then let's dive right into some of the stuff that you guys built using serverless technology from AWS.
Sure. Yeah. Well, I think many people are very familiar with Fender. We've been around since 1952, but the creation of the iconic Telecaster and then later the Stratocaster, Precision Bass, Jazz Bass, Jaguar, Mustang. It's that and amplifiers as well from tube. We still make tube amplifiers and tubes, and also have a very good line of connected digital amplifiers as well. And I'm part of Fender Digital. And Fender Digital, we do all of our flagship product is Fender Play, which is a digital learning application for people to learn how to play guitar. And we also have so that's one application we have that's both on Android and iOS. We also have Fender Tune, which is a tuner, guitar tuner. That's also Android, iOS, and the same thing with Fender Tone, which is the companion app to our Mustang GT amplifier series, allowing you to remotely control your amplifier and share your presets and settings with other users of the community.
That's interesting. So and I know we're not here to talk about that bit, but the tone thing, is that like, are these modeled amplification, or are you just talking about your amplifier, your own settings are digitally recorded and you can then pass those off and preset them to someone else?
These are our digital modeling amplifiers. So we have the Rumble bass amps that just came out and the Mustang GT guitar amps. It's like having a big pedal board all within your amp.
See, Andy, we can start going all different ways on this. And so before we dive into this, Andy, I did just want to bring up for our listeners, we are going to be talking about serverless and Lambda a lot today. And if you're just a little bit still shaky on the whole concept of serverless, go back. I just looked it up. Episode 42 is where we did kind of like the 101 on serverless. So if some of this might be a little bit confusing in terms of how serverless works and everything, go back, listen to episode 42, then come back and listen to this one, and it'll probably make a lot more sense, hopefully. But with that, go on. Sorry.
Okay. So we can dive right into some of the topics here. We can start out talking a bit about serverless performance and some of the things that we've encountered and on our experience and what we've learned from that.
Yeah, that will be perfect.
Great. So one thing that you hear about quite a bit, at least with AWS Lambda, is a cold start, which the first time a function is invoked after code is deployed, or if it's been idle for a period of time and they've recycled the container underneath you, it actually will download your code, initializes the container, and gets it started. So there can be a brief delay on that initial invocation that could result in like a user getting a slow response. If you return an error from a function, because usually the function arguments you can return both a payload and an error. If you return an error, it will end up triggering another cold start on it. So that if you can avoid returning errors when necessary, especially in a synchronously invoked function, it's a really good idea to do. Another thing that can really make the cold start time longer than you anticipate is using a VPC. So if you need to access resources within your VPC, say an RDS database or your own internally set up Elasticsearch cluster or whatever other resources you need, it has to attach an ENI onto that container, an Elastic Network Interface. And it can take up to 7-8 seconds for that cold start to really occur to get that ENI attached.
So every time you start, that has to get attached to it. It's part of like the build out, right?
Correct.
Okay.
Yes.
That's interesting. Yeah, I hadn't thought about that.
And one thing to really worry about with the use in VPCs is that by having your Lambda functions in a VPC, those ENIs, the quantity that you have available to you, they're limited at the account level. So if you have a large number of functions and they're all attached into the VPC, once you hit that ENI account level, it's not going to, with a big request spike, it's not going to allocate more containers and you'll start returning errors back. So one thing you can do to sort of help prevent that is, well, only use a VPC if absolutely necessary. Like if you're accessing Amazon services such as S3 or DynamoDB or the AWS Elasticsearch service, you don't need to use a VPC. And if you do, the AWS Lambda now has concurrency control, so you can limit how many instances of a container will be running at any one time. So you can kind of get an idea of what your ENI limits are and ask for account limits if you actually do need to access resources in the VPC. Other things we've seen is is our reuse of HTTP connections between invocations. All our Lambdas are written in Go. We've done that from the beginning, from last year, even prior to the native Go support that AWS launched this last year. We use a framework called Apex, which uses a Node.js shim to run the Go binary. And we use the client is called Elastic. It's the Golang Elasticsearch client, and it'll keep the HTTP connections around in the back end. But we found that between invocations, it's like they go nowhere. So we actually have to close up the connections and after the function invocation, before the function invocation completes, and release those resources. Mm-hmm. Yeah. Another good tip for performance is definitely take advantage of, especially if you're using API Gateway in front of your functions, API Gateway caching. We have that on our CMS and lesson items. Items don't change very often, and we get a greater than 95% cache hit ratio. So that really saves us a lot of function invocation times and makes it very fast for the end user.
Can I ask a question on that one? Because a lot of this, I think, both Andy's got quite a bit more AWS experience than I do, but I think for a lot of our listeners too, it's a lot of new stuff. So obviously, I know the API gateway in front of the Lambda function. So you're saying you can use that API gateway sort of as a caching layer, so that when you invoke or when you call data from your Lambda function, you're storing it in there and running there. So the next time you make a hit, you don't actually have to make a call back to Lambda. Is that kind of the architecture you're speaking of?
Absolutely correct. Yes.
Wow. That's really cool.
Yeah. And we actually hit it up we use it heavily within our CMS. And whenever we publish updates, we can actually, our API, when an update is published into production, we actually can flush the cache to make sure those new changes are available right away and it doesn't take 20 minutes to show up.
And Andy, this makes me think of, we see so many of the same problem patterns over and over, especially going from the monolith to microservice kind of style. And even though serverless is considered this other kind of thing, it really isn't. And you still have the same problem patterns to avoid. So it's just to me, the interesting idea of throwing caching in front of Lambda functions so that you call less of them, thus saving the money of hitting them, is really a very interesting concept.
Yeah, I mean, in any type of architecture, right, if you have content that doesn't change that regularly, the closer you can get it statically to the end user, the better and the cheaper it is. Now, Michael, I have one question here. For people that may not know the API gateway that way, then the option when it comes to caching, does the API gateway cache itself, or is it where you're using S3 or CloudFront as a cache, or how does this work? And is it configurable in the API gateway rule definition on where it's cached and how the cache works?
Yes, you can actually specify what your cache size is, and they do charge you based on, I think, an instance size type of thing. So you can have a larger cache or a smaller cache. And it is cached it's a feature actually within API gateway itself. And you can specify which routes are cached, which are not, and what would make up the uniqueness of a cache key. So if you want to cache it based on a user level, you can have your authorization header as part of the cache key.
Mm-hmm. That's cool. And actually one little piece of information you didn't mention, but it's in your notes for the podcast, was the costs that you have for Lambda. And that was actually quite fascinating because if I read this correctly, you said $80 per month that you paid for Lambda. But can you also kind of tell us what the costs are for the rest of the infrastructure? Because $80 seems like nothing for your Lambda. But then knowing that 95% of the requests never hit Lambda, what's the cost of the cache as compared to if you would push everything through to Lambda?
Oh, the cache cost I don't have off the top of my head, but I don't think it's very significant. So our original services that we started building about 2 years ago were all based off of EC2-based microservices. Mm-hmm. And then in early 2017, we just skipped right over containers and dove wholeheartedly into Lambda. So one of our EC2 services that is still running is our authentication service. So averages about 4 requests per second. These are C5 instances. We have used 1 year reserved instances, and for 2 of them, it costs us $80 a month, and it's 2% utilization. Whereas all of our Lambda functions, which includes everything that supports Fender Play, Fender Tone, and Fender Tune, that's about 40 invocations per second, and that costs us $80. Mm-hmm.
It is fascinating, right? If you think about this new world where we talk about these costs, and then it's amazing how low these costs seem for something that you run, right? You run your online business on $80 worth of Lambda and $80 worth of EC2 for your authentication service, and it's fantastic. It's phenomenal. And
I also love the fact that you skipped right over containers. That's I think that's a first that I've heard. That's really, and it's funny, and like just in my head, I keep on thinking, like, as you're explaining all this stuff, I'm like, who would have thought Fender, a guitar company, was so advanced? It just goes to show you never know, where all the smart people are. Like again, Andy, going back to Capital One, with okay, it's a bank, but like they're super advanced on their tech side. So it's just always cool and shocking to hear who it actually is. Not that we thought, not that I ever thought Fender would be like some backwards technology company, but never in my head, like, who do you think is cutting edge?
Mm-hmm. Yeah. Well, hey, and Michael, I got one more question. So you still have the authentication service running on bare EC2, and did you say what technology stack that is?
That's a Golang-based microservice. We're using an RDS-backed instance for that. Due to the cost savings and also so we can make our application multi-region, we're going to be migrating that either to Cognito or our own serverless-based solution.
Okay.
Cool. And in terms of performance, you also had mentioned something about memory. We kind of cut you off before you got to that one, but there's some talk about testing there, so I want to make sure we get to that one because that's going to be interesting, I think.
Yes. So with Lambda functions, you can allocate memory anywhere from 128 megabytes to just over 3 gigabytes. And CPU increases proportionally with that memory as well. So even if your function is maybe only consuming 50 megabytes of RAM, you may want to give it 1.5 gigs to make that fastest response. It's kind of a bit of experimentation to find out where that sweet spot is between memory allocation and performance. For synchronous functions, we generally use 1.5 gigabytes or more. Asynchronous functions that are more event-driven, those we tend to go with a lower amount because it doesn't matter if it takes an extra 100 milliseconds to execute.
Now, when you're setting up Lambda for this, I know part of the pay is for how long it's running, right? But does the memory or CPU consumption come into account on what you're paying for? Or is it just strictly time, in which case the idea could be, as you're saying, find that sweet spot, and if it needs more CPU and memory, run it because it might actually cost you less. How does the pricing work for that?
The pricing is a combination of both time and how much memory. So if you're allocating more memory to a function, it's going to cost you more per 100 millisecond increment.
Right. Okay. So all right. Good. That's interesting too.
Hey, and do you, Michael, if I may ask, because this is very interesting. So part of your performance engineering then in pre-prod is to actually find the sweet spot per function. So that means we're expecting that type of load, and we want to find the sweet spot in terms of the memory setting and the CPU setting on my serverless container. That's part of your pre-prod performance engineering?
Yes, we play around. We mess around in our active environment whenever we're doing testing and developing to see what would be best.
That's cool.
That goes back, Michael, that goes back to something Andy's been trying to encourage people to do for a long time now, has been finding the cost of your deployment. What's the cost of the new code and how can that be done? And I think, that's just a perfect example of it. And I think with Lambda, by the way it's priced, it's very, it's just right out there. You could see it very clearly. So I think that's an awesome metric to add into that.
I was 2 weeks ago. I had the chance to meet up with one of the guys at Google in Zurich, and there we talked about the cost of a request. So they're actually measuring the cost of every single request, and then based on that, make decisions on how to scale up the individual services and actually how to redirect traffic and how to kind of throw back requests to the calling side. And it was very fascinating, similar concepts, but very cool stuff that you guys are doing here. And also I thought what Google was doing there, trying to really measure every single request and based on that then make the decision on how to scale or which requests are kind of rejected back to the initial caller. And then hoping that the initial caller is retrying and then hitting a service potentially that is less expensive. So there's different things, different thoughts that we bounced off when we made this discussion. Cool. So performance, cold starts, VPC usage. Yeah, go ahead.
Oh, on the memory setting, I have one quick thing. One thing we really want to investigate is actually doing CPU profiling on function execution to find out when you get no more return, so you can kind of crank it up to the memory, and after a certain point, you don't get any, you get diminishing return, so you know where to keep it at. You kind of use that tool to kind of determine that.
Yeah, cool. In terms of and I know I'm looking at our notes here, and I think this was fantastic. So we talked about cold starts, the VPC usage, the reuse of HTTP connections, the API gateway caching, and also the memory settings. Now, obviously, big question here is, all of these things need some type of measuring and monitoring, right? I assume you are obviously having your own different tools that you're using. There's a lot of stuff out there. Can you fill us in a little bit on how you monitor? And obviously we, with our background in monitoring, would also be interested in what the shortfalls are of APM, as you put it in your notes. That's very interesting, because this is where we want to learn and how we can say, hey, okay, what can we do to help companies like yours to get better insights into architectures that you guys are building?
Yeah, so we rely very heavily on CloudWatch logs and CloudWatch metrics for measuring performance of our Lambda functions. Mm-hmm. And we actually, we have APM tools, say, such as like Datadog or New Relic. What they'll do is they'll have an agent that, like with Datadog, there's an agent that runs on the server. Well, you can't use that agent in a Lambda function. With something like New Relic, they've got a Golang API client, but it batches up requests. It's meant to sort of funnel them off like once every 30 seconds to push those stats up to their servers. And while it is possible to configure that client to flush those stats before the invocation of the function ends, it adds time because it's got to send that up to the server. So your error functions ended up taking an extra, 50 to 100 milliseconds to execute to flush those stats. Because even if you've got that client that's batching things up, your container could go away. If you got one request and if it's a seldomly invoked Lambda, there may not be another request for 10 minutes, that performance data is gone. So that's the major shortfall with those APM tools, is they're flushing things out to a third-party service.
Yeah,
but with CloudWatch, CloudWatch metrics have all that stuff.
Mm-hmm. Can you? Yeah. Sorry, I will come back to that later on. Yeah, go on, and then I have some comments on that, and also ideas and thoughts. Yeah.
Oh, sure. Go ahead. I'd like to hear your ideas and thoughts on that.
So I mean, it's interesting because these are obviously the challenges that we also heard from people that we worked with in the early days of serverless. And as you just said, it's not possible to install an agent on a machine that you can't control, because it's AWS who controls the underlying machine, and you don't want to batch up any data that is then asynchronously sending it back at some point, and then you potentially lose it if the container goes down. So without obviously too much of a commercial here, but you should definitely look, and the audience, the listeners should check out what we have done when it comes to serverless monitoring, because we figured out a way how to trace requests end to end. And I know you're probably going to later maybe talk a little bit about X-ray. But one thing we have done as a tool vendor in that space is making it seamless to actually trace Lambda functions end to end. And we've done this for Node.js in the beginning, and also for Java, and Go is on the list. So that's why it will also be very interesting then once you dig deeper into how you get better transactional data to get your feedback then actively from the way we are doing it. So because we heard these problems, and I believe we are on the right way of, we solved them for Node.js and Java already, and for Go, that's on the list. So that would be very cool. But we heard the same thing, what you just brought up.
Yeah, whenever you have a Go client ready, I would love to dig in and play around with it and see what it does. Yeah, so CloudWatch logs and metrics is what we use for capturing all our performance. And we actually just use Datadog for sort of dashboarding all those metrics and within there. And they have a neat functionality with custom counters as well, where if you write a log entry to CloudWatch logs formatted in a specific way, you can actually create metrics and tag them. So if you have certain events or want to keep track of response codes from a third party, you can actually set counters and alerts around that. Now, the downside with CloudWatch logs, so we look at, if you think of a traditional microservice, we sort of do that same sort of approach with Lambda. So a collection of Lambda functions that operate on a given business domain is a service for us. And the advantage to using Lambda is you can have multiple inputs to the service, whether it be SNS, direct invocation, S3 events, DynamoDB streams, web requests via API gateway, and have like shared business logic among these functions, and just have all these different inputs and responding to different things. And with all those different functions, CloudWatch logs, those logs are siloed for each function. And so it's really difficult to kind of see like, oh, this request went here and then it did this, and what happened, and what services and functions did this touch in that. So we actually have a Lambda function that feeds off of all our CloudWatch logs. And this is a Lambda function we have that actually is part of our VPC because it dumps it into our own Elk stack. So all of our logs will get dumped into that so we can actually see them in one unified spot. And we also recently started using a tool. I'm a very big fan of honeycomb.io. And we sample our logs and we send them up to them. It's very, very fast and easy to dice through if we have issues and kind of find those unknown unknowns and really discover what's happening with your performance. And you mentioned X-ray tracing. It's something it's something on our list to do this year. We haven't really dug into it yet because with using the Node.js shim with the Go binary, we could use X-ray, but we would have to manually create all the segments and set everything up. Now with the native Go support, we should be able to use X-ray so that it automatically tracks all our requests to publishing to SNS and calls to DynamoDB and things of that nature.
Yeah, that's pretty cool. So let me ask you a couple of questions here. So you said the way you solve the CloudWatch quote-unquote challenge, where the metrics go into every single, are obviously collected by every single function. You're pulling the data through a CloudWatch event, and then you're pushing it into a central, you said Elk instance, right? That's what I think what you said. Yeah.
Yeah, we just feed those logs in.
Yeah. What are the biggest, what are the patterns you're looking for? Is this, what are the main use cases? This would be very interesting. What are the main use cases you are detecting by looking at these logs that are coming in? What are the main things you find every day?
Main thing we're looking for is sort of performance. So we can do a heat map and see what's going on with the time of the function invocation, if we're seeing a lot of errors, what the status codes are coming back, and actually dig in. And actually, if a problem happens, that impacts customers, we can actually get a list of those customers and provide that to our support department so they can preemptively reach out and contact people like, hey, we understood you had a problem signing up for a subscription. We apologize. Everything's been corrected now. Things like that.
Cool. And I assume you have set up some alerts, like it means if you have a failure rate of, let's say, higher than 1% or 2% or higher than usual, then you proactively feed this information to your support team, or is your support team kind of more reactively pulling this data in?
It's a little bit of both. So we get a bit of reactive if for like one or two things go through, but if we see something large and we can be proactive about it, we are.
Mm-hmm. Cool. And when you say you see something, then you become proactive. That means you mean your team that is constantly looking and analyzing the data and keeping an eye on kind of the health status of your system, and then you are alerting the individual teams in case something is abnormal, or did you also build in some automated mechanisms?
We have some automated mechanisms through that will alert to PagerDuty if 500 errors, they exceed a certain limit. I also engineers will set up specific alerts for things that they're kind of keeping an eye on. One thing that we recently had an issue with was we had a production release to our subscription management service, and everything passed successfully in QA, but we had an issue in production due to a configuration with how our subscription billing provider was configured in their test environment versus their production environment. And we were able to quickly see that when it was happening and know that, it was tied to this release, we need to roll back. And it's also prompted us to start looking into the canary deployments and traffic shaping within Lambda to modify our release process so that the releasing engineer that releases it out in production can say 20% of traffic will go to the new version, kind of keep an eye on things, and then decide whether or not to go 100% or if we need to roll it back and investigate something.
Mm-hmm. No, that's pretty cool. We talked about this before we started the recording, that this is a very exciting topic and that we see a lot out there. And that's, Brian and I, we both have been in the testing space for many, many years. So obviously we know how much it takes. I mean, that we should all invest in testing early, testing often, testing automated, but certain things, you can only really, find and experiment with in production with real users. And as hard as it is for me to say, sometimes our end users are our guinea pigs. Sometimes that's the way it is.
Production is the new. There was the old remember I think it was, forget what beer it was, but there was the most interesting man. Remember that campaign? There was that got like commandeered for a lot of other memes, and one of them was a picture of him, and it says, "I don't always test, but when I do, I test in production."
Exactly.
Exactly.
I've seen that one many times.
Yeah. Hey, and Michael, to the Canary deployments that you're looking into, and you said you will have the ability to say 20% of the traffic, try it out, get the results, look at the monitoring data, and then decide is it good enough or not. Do you know that feature that AWS provides, the 20%, is this something that would then be sticky to end user sessions? It obviously has to, right? So you can control it by user stickiness or by session stickiness or by geo, or do you have any ideas or any insights in how this traffic shifting works?
We're just investigating it now and seeing what we need to do to modify our processes to take advantage of it. I'm not sure I don't believe it does anything with user stickiness, but that's actually a very good point and something I would want to follow up on.
Yeah, because if you do it 20% across all the requests, you may end up having individual users, hitting different versions, or the same user hitting different versions of your function. It has to be somehow sticky to your end user, which, is for me the only way that makes sense, because otherwise you end up with a combination of different versions for a single user. That might be challenging. Yeah, I wanted to go back to some of the stuff you said on the monitoring side, because I think this is the problem that you solved with your architecture, where you are combing through the logs and then you are looking at the performance metrics and then you are alerting on failure rates and all that. I mean, it's great to hear that you're doing this, and it just, I think for me, it's a confirmation that we've also been doing the right thing. So just to give you a little background on what we are doing, and I'm sure the other, APM vendors in the space or other monitoring tools do it in a similar way. We're automatically doing multidimensional baselining, as we call it. So we automatically baseline your response time, failure rate, and throughput based on individual endpoints. So in your case, it would be your individual functions. And then we calculate baselines, and then we can alert based on baseline violations. And then we would, for instance, I think you mentioned PagerDuty, right? That's the tool using. Then we can trigger that. So that's good to know. So you're watching out for the same things that we've built into the product. I'm looking at your presentation right now, because your presentation is up on SlideShare on the Amazon Web Services SlideShare account. And I mean, stuff that you explained verbally you have some very nice architectural diagrams where you see Lambda functions calling other Lambda functions and then going into DynamoDB and calling other Lambda functions. How often does it happen, or how many hops does a request take from, let's say, a mobile app all the way until the very end? Is it 1 hop? Is it 2 hops? Is it up to 5 hops? How many hops does a request take?
So to service a user request, there's generally just 2. It hits a custom authorizer, and then it hits the function that actually executes the business logic and returns the response. But then in the course of handling that response, say something is written to DynamoDB, then there's a function that's not tied into the request, but feeds off that DynamoDB stream and, say, decides whether it needs to raise an event. So, for example, let's say when someone modifies their subscription or starts a new subscription to Fender Play, the DynamoDB stream function off that table looks at previous state of the subscription, current state of the subscription, and decides whether or not it needs to raise an event that the subscription has changed. And that event gets raised, and it can get picked up by different applications. It's currently picked up by 2 applications: one that updates our email service provider, and one that updates our data warehouse via segments. And then it's all happening asynchronously in the background after the users made their request.
Yeah, that's pretty. I mean, I can really encourage. We should. I want to definitely, if it's okay with you, put the link to your slides up on the podcast page, because it's really fascinating to see that. Yeah, the reason why I mentioned, and I was asking for the number of hops. So one thing that I've seen,
because you're Austrian and you have beer on your mind.
That's true. I just So I said the word hops several times today, right? Yeah, that's right. No, that's good. The reason why I'm talking about the hops, meaning from service to service, and not the ingredient that makes the beer what I call beer, is I see it a lot with our customers or people that we interact with, where they're also going down the microservice route or the Lambda, the serverless route, and then even employing or including things like service meshes. And they think about all these things that in the end up with very deep service call chains, as I call them, right? You have one service calling the next, and whether it's directly or indirectly through a table like DynamoDB. And what I've been advocating, and I would like to get your feedback on that, what I've been advocating is treating a microservice like a LinkedIn profile. And here's my analogy, just to make that this makes sense. If I look at my LinkedIn profile, I have connections in my first grade and my second grade connections. So let's say I have 100 first grade connections, and these 100 connections have 1,000 second grade connections. And when you think about a microservice or a serverless function, you have the same thing like a LinkedIn profile. You have incoming connections and you have outgoing connections first grade, and then these first grade have second grade connections. I believe we should start also not only looking when it comes to performance on the real performance aspect of a service like response time and throughput and CPU consumption, but also the dependencies, the incoming, outgoing, and when it goes to outgoing, not only first generation but second generation of connections. And then if we keep track on this, in CI/CD, even if changes coming down the pipeline, we can immediately see if a code change or a configuration change or including a new library, if that changes anything of the dependencies in my first generation and second generations. Does this make sense?
Yes, that does, yeah.
Because you mentioned, right, you're using caching, and if you are saying, or if somebody makes a mistake, mistakes can happen, and somebody misconfigures your cache, or somebody removes a caching layer between two services, and all of a sudden this missing caching layer is increasing your dependencies by factor X, then you want to be aware of that. But you might not be aware of it if you only look at response time of the service endpoint. So I think looking at these dependencies and the hops, and in first generation, second generation, this is something that I've been trying to advocate, and what we have, within our Dynatrace platform, we have the ability to give you this information on a service per service and function by function level. We call it Smartscape information, where we have the smart dependency map, the live dependency map, and we can actually traverse the dependency tree through an API, which makes it very easy to use in a CI/CD setting, but also for constant validation in production. And I want to see what you think about this.
That sounds like a very compelling tool, especially when you mentioned earlier when you talked about the baseline. So if a service is generally performing at a given point, but then all of a sudden it's gone up beyond that point, but it's not returning an error, that's something you would want to know about and investigate before it became an error. And definitely all those dependencies. We try to minimize the dependencies between functions. There's only a handful of services that actually call out to other services in executing a request. But we try to kind of keep things as much contained as possible.
I think that's the tricky part right there, right? Because the whole spirit of microservices is, well, at least in one aspect of it is, here's my service for anybody to use, and then not knowing who's using it gets really, really tricky. So the idea of trying to keep it under control, I think that's just in general the alligator that everyone's got to wrestle when they move over. I don't have any advice on how to control that, but you just control it the best you can, I guess, and hope that it doesn't get too out of hand. But at least knowing what those dependencies are, I think is a good key element to that. And obviously, it's not like if you're one of these extremely large, let's say, banking organizations that have, within them, there are almost 30 different companies. That's where you can start getting really out of hand. I think the smaller you are, the more control you have over that situation, for sure.
Exactly. We have a very good, very small team here. We have 4 engineers that work on the back end services. So everyone's familiar with everything else, and we kind of switch off. So everyone has familiarity with all the different services and how they interact with each other.
Oh, that's a great practice, the switching. Yeah.
Cool. Michael, I know you gave us a lot of great insights in performance, what you're looking for when it comes to performance. You talked about monitoring. Any other best practices maybe that you have for our listeners once they start their journey down towards Lambda lane or serverless lane?
One thing to sort of keep in mind, and we're sort of, is function explosion, like a large number of functions. So with our API gateway invoked functions, we decided to go down the route of a one function per route method combination. So that, rather than having like a router and using API gateway as a router and directing it to different functions. With language, if you're using Node.js or Python-based serverless servers, you're not going to really notice much of a difference. However, with compiled languages such as Go or Java or .NET, the more functions you add, the longer and longer that build time is going to take, and until it just becomes unacceptable. So, controlling the amount of functions and we're now looking at ways to sort of reduce those like functions per event source. So if API gateway is an event source, okay, that's one function, and we're going to have a router, a muxer inside that function and handle all the different types of requests within that. And if we've got to listen on a specific SNS topic, or a stream from a DynamoDB table, to sort of limit those amount of functions just to the distinct inputs that you have. That's a big one. Another one is our timeout detections too. So you can set the time limit for a Lambda function. I think the shortest is 5 seconds and the longest is 5 minutes. However, when you hit that timeout, we rely on structured logging within our functions. We use a library called Logris to provide JSON formatted logging into CloudWatch that we then forward onto Elk. And if the timeout occurs, it's not a structured log that goes into CloudWatch, so we don't really see it. So capturing those timeouts, say 200 milliseconds before the function AWS would pull the plug on you to cancel it and log something meaningful and return an error response to the user. That's a big piece.
Do you get a chance? Is there a callback or is there a log that Lambda is writing in case it kills your function?
It does. It does write it to CloudWatch logs. It does say, a function exceeded, I forget the exact text, function timeout. And then when your function timeout, you get hit with another cold start on the next invocation as well. So if you can actually capture those timeouts, like say you're calling a third-party service that's a little flaky and sometimes it hangs, if you can capture those timeouts and return an error before the function itself times out, you can minimize your cold starts. Yeah,
that makes sense. That's a good one. Thank you. Yeah. Anything else on the best practice?
A couple other simple ones is if you're doing very simple DynamoDB CRUD operations that you don't even need a Lambda function, you can just go through API gateway and use a velocity template mapping to delete items from DynamoDB. We use that within our Fender Tune application for users to create their own custom tunings and save them to the cloud. And there's no functions at all involved. It's just straight through API gateway mapping using a custom authorizer so we can get the user ID out of the authentication token.
Cool. So that means this allows direct REST access to do CRUD operations on the DynamoDB without having to write any Lambda function in front of the DynamoDB that actually converts the REST call into the DynamoDB API call. So that's really sweet. Yeah.
The only downside to that approach is logging if there are errors, say like if you have an error within your template. And we're looking at beefing up our testing processes for those templates so that we can, because right now it's sort of a bit of an experimentation. You're playing around with the template. Does that work? Does that work? And sort of manual testing. We're looking at ways to automate that testing for those templates. And one last thing that we're doing more and more now is using step functions for decoupling functions. So Amazon step functions allow you to say coordinate function invocations and do various things. Like we use Elasticsearch for full text search within our Fender tone for the community presets that are shared, and we fill that index from DynamoDB stream table. All the data stored in DynamoDB. The stream function updates the Elasticsearch index, and we also, for disaster recovery purposes, we need a way to refill that index from scratch. And it takes longer than 5 minutes to do that operation. So we have a step function that invokes the refill function with an empty JSON document. And then if that function returns with, say, that the last evaluated keys from DynamoDB table, the state machine actually invokes the function again, using that as the input to continue where it left off. And that way it just kind of loops through invocations until the refill is complete, and then the state machine stops. And other use cases would be, say, you were handling reporting events that are coming in from the front end that maybe have a bare bones minimum of data. So you could have that come in to a step function, which you can actually invoke step functions directly via API gateway. And you could have that function come in, and then maybe it calls like one function. You need to, say, aggregate data from 3 different services before you publish this denormalized data into the data warehouse. So rather than having one function that's coupled to all those 3 services, you can actually add that data via the state machine. It's sort of like, I'm going to call this service from that and get this data and kind of keep all that data together and then finally send it off to your final destination.
Mm-hmm. This is actually one of the painful lessons I learned myself when I started implementing my first Lambda functions. I approached Lambda in the traditional sense of how I solved problems in the old days when I was coding, I don't know, C# or Java, very synchronous and very like a big block of thing, and I'm doing A, B, C, D, and I'm waiting until A is done, then I'm doing B. And I'm not sure how you may have solved this problem with your engineers or your architects to also change the thinking towards what you just explained, right? Using step functions and basically using state machines to break down bigger problems into smaller pieces. And when I started developing, I really made the big mistake of just trying to synchronize as much as possible and then have one Lambda function that called other functions and always waited on them. And obviously, which is stupid, because I had to, you pay more because you pay for the main function, waiting for the other function. You also have to wait for the other, also have to pay for the functions you call. And obviously you then run into the potential problem that you guys also solved with this is timeouts. And I'm just wondering, did you have anything, did you educate your engineers on what is, how do we properly use Lambda to leverage its full potential?
I would say our engineers are very good at educating each other and researching and playing around with things and experimenting and seeing what works and keeping up on Amazon's new technology and product releases. It's very much a team effort to even put all this information that we've discussed today. I certainly am not alone in it. I'd have to thank everyone on the team for all the work we've done to sort of really make this work for us and be successful.
Cool. Well, and I also want to say a big thank you for you really to come on the air and educate. I mean, Brian, for me, this was a lot of great information on serverless. And yes, we had the one-on-one on serverless, but this was a real great experience report. Yeah. This
is like real. I would say this is kind of a real world advanced. You know, the kind of things you hear are possible with serverless. But you don't really hear about people doing it. This is kind of like your Fender's doing it, you know. But Andy, did you want to go ahead and summon the summarator then? We'll wrap things up.
Let's do it.
Yeah, I want to wrap it up. And so again, Michael, thank you so much. What I learned today, there's a lot of things when we move over to the serverless world that we have to understand. We are no longer in control of the underlying container or the underlying hardware, obviously. So things like cold starts that you talked about, and how we can avoid cold starts. You talked about we need to think a lot about caching, so we can cache, obviously, a lot of the dynamic response from our Lambda functions using built-in features of API Gateway. In your case, you had a 95% cache hit ratio. I liked what you said about doing performance engineering to figure out the optimum setting of memory CPU when it comes to price and performance, finding that sweet spot. Then I think we all have to rethink and relearn on how we do proper monitoring. There are monitoring options out there, whether it's CloudWatch, whether it's X-Ray, and as Michael, you have shown us, you can do a lot of the built-in stuff, but it also takes obviously some work and some thinking of streaming the data to Elk and then doing an AU analysis. That's a kind of like a reminder for us as tool vendors to understand these use cases and then build something that works out of the box and solves all of these use cases, because you should not need to figure out how to get the best out of the data, how to figure out if something is wrong, and how to figure out if there's a higher failure rate and then notify the people. This is something that you should expect from modern monitoring tools. And then in the end, thanks for the great best practices, breaking the big functions up into smaller pieces, using step functions to decouple big functions. And another last thing that I kind of take back home with me is using canary deployments to really test new features out in the wild and see if it's really working, if we have missed anything in testing, and then either broaden it up to the larger world or kind of rolling it back and let engineering work on a better solution in case there are problems. So thank you so much. We will definitely make sure to link your slides that are up on SlideShare with the podcast. Any final words on your side? I think Fender is obviously a great company to work for.
You stole my line, Andy.
Sorry.
Yeah. Fender is a wonderful. It's basically, I'm at my dream job right now. This is a wonderful place to work. We do have openings at this time. I encourage people to check out the Fender website. We have an office in Scottsdale, Arizona, and in Hollywood, California. If you're interested, take a look and see what we have available and reach out. And Fender also has a very big social media presence, so be sure to check out Instagram and Facebook and everything else that has Fender. The Instagram feed is wonderful. Great photography.
And bonus points if you can play a version of your resume on guitar that transforms itself, the sound transforms into the actual printed resume when they play it back.
That would be something spectacular.
Right.
Yeah.
Which you have to do with it, but it has to be recorded with a Fender guitar, of course.
Yeah.
The one thing I wanted to just point out, Andy, and Michael, again, thank you so much. Great stuff here is, Andy, you and I have talked a lot about different performance considerations. And for a long time now, it seemed like old performance is the same new performance, meaning every old performance problem pattern that you'd come across in the past carries over into any new platform. Once we started going to microservices and containers, it's still the same problem patterns we're looking out for, the same most common mistakes. But as Michael pointed out here, it to me at least, when he was talking about these performance issues, the VPC usage, cold starts, even using the caching layers, especially the one I love the most was the CPU memory balance and defining that sweet spot. This sounds all new to me. It sounds like there are new performance challenges, new patterns, new things to look out for a lot more. I mean, every new kind of technology comes with a few new ones, but the serverless has it seems like it has a whole larger spectrum of new performance considerations. And I think we're going to be finding out more and more of them as their usage advances. So I'm just excited about that. And to me, that was very exciting to hear, Michael. So thank you for sharing it.
You're welcome. Thanks for having me on.
Right, awesome. Well, thanks everyone for listening, and we'll catch you next time on Pure Performance. Thank you very much.
Thank you.